What can we as technical data professionals learn from a 17th century samurai? As it turns out, there's quite a lot. The Book of Five Rings is divided into 5 sections, each representing different principles: earth, water, fire, wind, and void. In this video, we'll look at how each of these rings can be applied to the world of data development. We'll see how Musashi's philosophy can motivate us to build more robust systems and adapt to new challenges. By the way, if you're new here, hey, I'm Alex. I've just created a Zen guide and workbook for data developers, and I'll send you a copy of that if you sign up for my free weekly email newsletter. There's a link in the description below. Miyamoto Musashi, who wrote the Book of Five Rings in 1645, was not just a samurai, but also an artist. On the surface, the Book of Five Rings is mostly about sword fighting, and that's definitely true. I read it. But there's a deep philosophical subtext. You don't have to look very far online to learn about this philosophy. The internet is overflowing with Musashi fans. And why not? The dude was legendary. He was apparently undefeated in over 60 duels and is one of the most legendary swordsmen in all of Japan's history. And what captivates me about Musashi is that his interests went far beyond sword fighting. He was interested in arts such as the tea ceremony and poetry and painting and, of course, writing. He spent the last 2 years of his life as a hermit in a cave in the south of Japan, which you can visit by bus if you lived around there. And in that time, he wrote the Book of Five Rings. The Earth Ring represents stability, grounding, and having a solid foundation. In combat, this is about having a firm stance and being well prepared before any action is taken. Let's talk about building a strong foundation in our systems. I've got a few things for you to think about here. The first is data integrity, and the question I'll ask you here is, can you trust the outputs of your system? So if it fails, you want to make sure that it fails loudly so you notice that. And consider how the end users will experience or notice these errors. For example, say that you have a data pipeline which fails halfway through a daily update. This could result in users seeing half of the data set, and therefore the metrics are all incorrect because they're only calculated on the half that they can see. But it might not be obvious that they're only looking at half of the data. Whereas if you make your update an atomic operation, so either the full day updates or none of the day updates, it's extremely obvious to the end users that that data is just missing. So they're not going to make the mistake of reporting on incorrect metrics in that case. Another aspect of building a solid foundation is reliability. You want to strive to build systems that can run for a long time without needing maintenance. I have a buddy who's working on a tech startup. Each day he spends hours working on the core technologies of his business. He's obsessed with building a solid foundation because he knows the long-term cost of poorly developed software. When you build something the right way, you can quite literally forget about it. This frees up your attention and your time so that you can focus on other things. And this is especially important if what you're building will be a foundational aspect of other parts of your system, if it's something that you're going to be building on that other technology will rely upon. The final aspect of a solid foundation is planning for maintainability. In this respect, you want to build in such a way that somebody else can easily understand how your application works. This should always be a consideration, even if you're developing independently, because given enough time away from the code base, you'll forget how it works. Probably you've all experienced this before, which leads me to the water ring. As Musashi says, a warrior must always be ready to adapt to the changing battlefield. For us as developers, this means we must always be ready to update our code based on the world that's changing around us. Musashi's idea here is to always be fluid and adaptable, like water, which changes shape to fit whatever environment it's in. In combat, this means adjusting your strategy to suit the situation. In software development, we can think about embracing flexibility in our approach and being able to pivot when necessary. This is especially true when working with data, where we have to adjust our approach based on the size of the data or the types of values in our data set, and based on those things changing over time. Consider a data pipeline. A well-designed data pipeline should be scalable, modular, and able to adjust to changing data over time. How this might look in practice is that it uses batches so that as data grows in size, the batches can remain of a fixed size, and we just increase the number of batches in order to process that data. The code we write is modular so that it can be reused across multiple data pipelines, and we anticipate upstream data schema changes. so that we have a way of handling the situation where the data today looks different than it did yesterday. I recently built a data pipeline that makes thousands of API calls every day in order to update a BigQuery reporting data source. In order to make this pipeline scalable, I used Docker Compose and worker replication in order to scale up a certain consuming service that I built. And in order to make it flexible to schema changes, I take the API response and I dump it into cloud storage as the full JSON response. And then I have a separate service that parses out the information in order to upload it to BigQuery. This also makes it modular because all of these services are separated. In this example, I directly control the volume of my data because I'm the one making API requests to request data to come into my server. But imagine you had a data pipeline that had an unpredictable volume and frequency, for example, event data, and you don't know how many events are going to be generated in a certain time. And in this type of case, you might want to build with a tool like Kubernetes that has auto-scaling capabilities, so you could handle that unpredictability. I just filmed a video on deploying an AI microservice to Kubernetes, so I'll leave a link to that in the video description and at the end of this one if you want to check that out. So this got pretty specific about data pipelines, but zooming out now, the water ring principle of adaptability can also be applied to the broader ecosystem of thinking about tools and technologies and making sure that you're able to adapt to what's new and what's working for people. Now, I need to be clear here. I'm not telling you to chase the newest tools. In fact, I'll tell you to be wary of them. Often in development, it's the old, tried and true technology that's the answer you're looking for, like Redis, like Postgres, things that I make videos about all the time. But there are exceptions. So I suggest following the center of mass of technologies. In this way, you don't get burned by adopting a transient technology too quickly, but you also don't get left behind. You essentially follow the pack. The point I'm trying to make is that having an open mind and being willing to change your technologies is key for long-term success in data development. Let's move on to the next ring, the fire ring. Here's where this video really starts to heat up. The fire ring is all about speed, decisiveness, and efficiency. In Musashi's teachings, fire represents swift, calculated action in combat, striking at the right moment to gain the upper hand, literally cutting your opponent down, as he would say. As we translate this into development, we're not focused on speed for the purposes of defeating some opponent, but for accomplishing the job at hand. Let's talk about data processing. Many businesses rely on real-time data, which means near real-time data processing. Reducing latency might come down to using more efficient algorithms, optimizing your database for queries, and using distributed frameworks like Apache Spark. In these ways, you can help your system handle large volumes of data in a timely fashion. So, while this need for speed is a real thing and relevant to Musashi's fire ring, I don't think it's particularly useful to talk about it. What's more interesting, I think, is the correct use of timing and moving efficiently in development. Let's think about how to prioritize what feature to build. You're going to either have users or business stakeholders coming at you with requests of what to build. Part of your job as a developer is to help them prioritize what to do, because they're going to be relying on you to know how long these things are going to take and how feasible they are in the first place. Here's a few questions you could ask yourself to help decide on what to prioritize. First, what's the easiest to implement? Then, what's going to have the biggest impact right now? And then what's going to have a big impact, but only over a long period of time? Thinking along these lines will help you get your timing right. And lastly, in Musashi's philosophy, speed isn't about being reckless. It's about being precise and timely. In software development, we can't sacrifice quality for speed. If you're rushing to deploy features or process data, you risk introducing bugs and inaccuracies. The key is finding that sweet spot where you're moving quickly, but still maintaining the integrity of your code and your data. So now let's ascend to the skies and think about the bigger picture with the wind ring. Apparently, the Japanese character for wind can also mean style. So perhaps this is why Musashi chose the Wind Ring chapter to talk about the various styles of different contemporary sword fighting schools in ancient Japan. There's two ideas that I want to talk about in this section. One, being aware of your surroundings and the strategies being used by others. Two, that mastery requires a deep understanding of the art. I want to discuss both of these ideas using one example from data engineering. The scenario is that you have a data pipeline which processes millions of events per second and aggregates that into hourly data for a data source. So with a broad understanding of the business context around how this data is being generated and how it's being used, you might come up with the following technical challenges. The first is performance bottlenecks. Processing such a large amount of data in real time could lead to challenges. The next is scalability, because the volume of data incoming might change over time. And that also could mean that the data outgoing will change over time. The next is data quality. This is an assurance which you need to make to downstream consumers of this data. And thinking about those downstream users as well, you could consider query performance, or how well that they're going to be able to access the data in a timely fashion once it's in that hourly data source output. Notice how all of these technical challenges are things that you have to see in your surroundings. They're not like what you're building in your code, they're outside considerations. So next, extending this awareness to the strategies used by others, you might consider the following solution. You might consider Apache Kafka for your event streaming solution. This is what's going to provide you that millions of events per minute data source. This is a scalable technology which is fault-proof, it's distributed, and has a long successful track record. Next, for the data processing component of your data pipeline, you might consider Apache Spark, which is a distributed data processing framework, and it's also suitable for streaming data. And lastly, you might consider a cloud data warehouse like Amazon Redshift or Google BigQuery to host the hourly results, the final output of your data pipeline, so that users can consume from that database, which can have certain optimizations for read query patterns, and also stores data very efficiently. So these parts of the example speak to the surroundings and noticing what other people are doing. Now I want to talk about the value of having mastery in your particular tools and having a very deep understanding of how those work. So on the implementation side, you'll need to make many decisions that will have a big impact on the quality of the final product. So being able to optimize performance and cost efficiency and ensure scalability and data quality of the final result, all of these things require a very deep understanding of the core technologies that you've chosen to use. So rather than getting overwhelmed with everything that everybody else is doing, just being aware of what everyone else is doing, choosing something that it seems like a good fit for your problem, and then understanding the components of that extremely well. That's what I'm talking about here with this wind ring section. And continuing along this idea of mastery, that brings us into the final section, the void ring. To me, this ring represents uncertainty, formlessness, and the unknown. It's a very short chapter in Musashi's 5 Rings book, and it's very philosophically based. He describes the void as the place where mastery and intuition intersect. Musashi writes that when your mind is clear and there's no clouds of confusion, this is the true void. And this is the perfect place from which to innovate. For example, think about the business problems that you observe in your organization. Not the ones that you're told to solve, but the ones that you observe. Being able to identify the pain points that you can solve with data and automation is a skill, and the void ring is where you can apply that skill. And this brings us back to the idea of mastery. Musashi writes, "Make sure that you base your practice on a wide foundation and learn a large number of martial arts. This way, you will be able to see the void as the way, and the way as the void." For Musashi, the void is where intuition lives. As you gain experience and always seek to understand the details of your craft, you develop an internalized awareness of the correct approach. In other words, you can trust that your gut feeling is in better alignment with the best thing to do. So in software development, this might look like making design choices without second guessing, because your past experience have honed your instincts. Thank you for watching, and if you've got this far, I'd appreciate it if you give me a like and consider subscribing. These small actions make a big impact for me here on YouTube. So let's recap what we've learned from Musashi's The Book of 5 Rings and how they apply to data development. There was the Earth Ring, to build a strong foundation by focusing on data integrity, well-structured systems, and constant maintenance. The Water Ring, be adaptable and flexible, embracing new tools and technologies and flowing with the changes in your system and your environment. The Fire Ring, optimizing for speed and efficiency, making sure to strike at the right moment with precision. And the win ring, understanding the bigger picture, industry tools, trends, and seeking out a deep understanding of your discipline. And finally, the void ring, to innovate, follow your intuition, and push against boundaries. I think it's so cool that the wisdom of this 17th century samurai warrior who spent the last 2 years of his life as a hermit writing some book has now reached us in modern day, and that a guy like me can come on YouTube and make a video applying these ideas to development. So whether you're a developer, a data analyst, a data engineer, and a machine learning person, I hope that the ideas in this video can guide you towards more effective, thoughtful, and innovative work. Just like a samurai who needs to constantly train and prepare for battle, we too need to continue honing our craft and gaining a deeper understanding of the tools and technologies that we use. Namaste.